So good morning.
Good morning.
Welcome to CPP Chat, CppCon edition. So, yes, our daily chat with guests from the C++ community. And to introduce our guest for today, I'm going to hand back over to John.
Good morning, everyone. I'm really excited about introducing and interviewing Sean Parent about his career change as a relationship counselor. So you did your keynote at CppCon yesterday?
Yep.
Not your first one?
Not my first one.
Are they getting smoother, or how's that changing?
I think everyone is more work. So,
Really?
especially with YouTube, because everybody now has seen my prior talk. So trying to come up with new material and put it all together is a lot of work.
Right. I heard you had 2.5 hours of material.
I did. So the day before giving my presentation, I did a full dry run in my room, beginning to end, telling all the jokes, trying to put it all together, and looked at my watch at the end and was like, well, that was 2.5 hours. So I was up until 2 o'clock in the morning editing.
So you want to tell us about the parts that were really hardest to cut out? Or do you want to instead tell us about your talk and how that went, and then we'll get to the...
Yeah, so, well, the talk is about relationships, and what I mean by that is components of software are related to other components of software, and they form structures, right? Values that are arguments to a function are related through the function to each other, and that forms particular structures. And so the general arc of the talk is understanding what relationships are, what structures are and how they come together, and then ultimately what architecture is, which is the design of structures and how you go about leveraging that to create better code. So that's the basic arc of the talk, and all of my talks I try to tell a story, right? Try to take it from some beginning and end, and follow everything through. So the editing process is really just going through and looking at, well, this is an important point or a story. I really love it, but it doesn't connect to anything, right? So try
Doesn't advance the plot.
Doesn't advance the plot, right? It might be an action-packed sequence, but ultimately didn't go anywhere.
So is there an action-packed sequence you want to share right now? An interesting story. I don't want to put you on the spot.
An interesting story about...
That you cut. Something that you wanted to say that kind of related but wasn't integral.
So the hardest thing to cut was at the end of the talk, I go through a small set of examples about using structure to reason about things, and there's several more kind of interesting things that you can get into. For example, if you haven't seen the talk, you'll have to go back and have the talk. But if you have an entity which is related to itself, right? So if you think about like X plus equals 5, or A plus equals B, that has A related to itself via B. Mm-hmm. Okay, so within your system, if you have both the A and A prime escape through your system, and by that you really meant that A was a single entity, then that's a potential contradiction and a source of bugs. And if you want your system as a whole to behave as if it were kind of a pure function, you have some inputs, maybe what the user does, and then it goes through and updates, and then it gives you a consistent result out the back, then that relationship that relates things back has to be idempotent, right? Which means f of x has to be the same as f of x. Mm-hmm. So plus would be a bad operator there. Min will actually work there, right? Min a equals min ab is idempotent. It won't shift. That's a difficult thing to explain in a talk, and so it's like, okay, it sucks in a little more math, so I need a little bit more up front. I'm not sure how many people are going to get it. So these are kind of, in my view, these are important things, but it's just going a little too far. It was already a little heavy talk with kind of the theory and the definitions.
But if you were putting it in a book, you might include that.
If I were putting it in a book, I might include that, yeah.
Any chance you might put it in a book?
There is a chance I might put it in a book. So after going native, this is where the C++ seasoning talk and my inheritance is the base class of evil talks became popular. I'd given those talks before, but that's where they really kind of took off because of high video quality and YouTube. Herb Sutter and a lot of other people said you should write a book. So I didn't really have time to write a book, so I started thinking as I would give talks, I would try to flesh out a section of the book. And so now I have kind of the outline, and this talk was the last chapter of the book. I've taught a course twice at Adobe going through the material, and I will go through it again in January. But about 3 years ago, I started a little project to take Photoshop and take it kind of off the desktop and turn it into an ecosystem. And so the first part of that will be Photoshop on the iPad, which we've announced and will ship fairly soon here. So 3 years ago, I had to call my editor and say I'm putting it on hold and stopping work. So we'll ship my product this year. Early next year, I'll start up the course and hopefully start writing again. And sometime, maybe before I retire, I'll get this thing shipped. Yeah.
So, do you have a name for it?
Better Code. That's the name for the book. Yeah.
But when you say that this was the last chapter of the book,
Yes.
does that mean you've done all the others, or just chronologically this one's going to be last?
That means I have given talks for all of the others. In the case of the original seasoning talk, that's really 3 talks together. If you go and look at it, there's 3 little distinct stories. So that's actually 3 chapters. Some of those I have given talks where I've split them out. So one section of that talk is really the inheritance of space class of evil talk, which is the chapter of the book talking about inheritance and polymorphism and things of that nature. Surprisingly, the most popular section, the algorithm section, every time I go to give a talk, I will frequently say, okay, well, I have this material. Do you want one of these talks? Or an option would be I could expand on the algorithms talk, and everybody's like, no, we want something new. So that talk has never been given as a full-length talk, the algorithms talk. There is an expanded version of the seasoning talk that I gave at A9, and that's online on YouTube. And so that was like a 2-part version of that seasoning talk.
A9 has some excellent videos.
A9 has some excellent videos, yes, with a good friend of ours, Alex Stepanov, who put those together.
Yeah.
And that was during your A9 time.
That's right. It was a great time for me. Sometimes I lie to people and say I worked with Alex. He was over in research, I did something else, but it was great to go to his talks and to talk to him and stuff like that. Learn from him.
Yeah, he certainly, had a huge impact on my career. So.
Yeah. You want to talk about how you met him and how?
Sure. So, kind of the way I say, the first time I met Alex was through his code, through STL, which is, I was working on Photoshop when kind of STL appeared. And, Photoshop, this big object-oriented application and very popular, and we kind of thought we had the basics figured out. And this STL thing was generating a little bit of buzz. And Photoshop at the time, C++ compilers, exception handling wasn't a thing yet, so you didn't have compilers that implemented exception handling. Inside of Photoshop, we had our own exception handling built on top of set jump, long jump. it was actually pretty effective, but that meant any external library that we brought in, we had to review it to make sure it was exception safe, and in many cases modify it to make it exception safe with our system. And STL was written pre-C++ exceptions, so it's not like it was swapping one in for the other. Now, to give a little background, the Photoshop team has a take-home test that's been given. Mark Hamburg started it, and I took the take-home test when I joined the team. And the take-home test is effectively, we give it to every engineer who's a candidate to be hired. It's a description of a binary search, and a very precise description, but and it even says in here, this is a binary search. And we hand it out to a candidate, and we say, take this home, don't get any help, write the code to solve this, and write a short description as to why you believe your code to be correct. It doesn't have to be a formal proof. We have received formal proofs, but a nice readable description. And one of the rules is if we have to spend too long trying to figure out if your code or description is correct, then it's not, right? And the rule is take as much time as you would like. However, be aware that we are looking for other people. So we extend an offer before you get this in. So that's kind of the rule. So I had seen.
So theoretically, someone you interviewed 6 years ago is still working on their formal proof.
Yeah, probably. I had taken this test, and then I had reviewed a whole bunch of these tests that had come in. And so then I see this STL code, and there's a lower bound in there. And it's beautiful, right? It's a perfect answer. And up to that point, well, up to today, we've seen 2 perfect answers turned in, okay? And one was very recently, and we hired her. The other one we extended an offer, but they didn't accept. So up until this point, I had seen 1 perfect answer for a binary search, and STL had the other, right? But it wasn't just binary search. It was everything in STL fits together like little puzzle pieces. If you look at STL, kind of all of the pieces, for the most part, are there to support in situ stable sort, which is up until STL was kind of a very difficult problem. It was rated as an open exercise, meaning there's no known solution in Art of Computer Programming in Knuth's book. And STL contains a very beautiful in situ sort, or in situ stable sort. And so I'm reading this code, and it's like every little piece is perfect, right? Every single piece, and they all fit together like puzzle pieces, right? People say like STL doesn't compose, which I think is BS. STL composes beautifully. So all these pieces fit together, and I'm like, who writes code like this? So that was kind of my first introduction to Alex, right? I want to learn to write code like this. So I was fortunate enough that a friend of mine at Adobe, somebody named Larry Macinter, worked at Bell Labs with Alex, and he invited Alex to come give a talk at Adobe. And so Alex came and gave a talk, and at the time Alex was a vice president at Compaq, and Compaq was in the process of being acquired by HP, so he was switching roles to being a vice president at HP and going through all of that. So he came in and gave a talk about STL, and afterwards I went up and said, I very much admire your work, and he asked what I was working on, and I told him. He said, that sounds very interesting, could you show me? So we ended up like spending 4 hours in my office looking at code, and at the end of this he said, this is so much fun, I wish that I could like just be an engineer. And I said, well, what's stopping you? And about 2 weeks later, my phone rang, and he called up, and he said, yeah, this is Alex, so I'd like to come work at Adobe.
And he didn't have to do the test at that point.
He did not have to do the test. He had already turned in his answer. It got very complicated because I was in research at the time at Adobe. I believe it or not, I couldn't pull him into research. So there's a long story there where Alex actually got hired and fired and hired again. And in the hiring again is when we finally created Adobe Software Technology Lab, and the name ST Lab, STL, everybody kind of recognizes that. And that's the group that Alex was in at HP. So, there's all, people think, standard template library or Stepanov and Lee, because it was, Alex Stepanov and Ming Lee who did the original HP report. STL was really an abbreviation for Software Technology Lab, which is where that originated. So we created Adobe Software Technology Lab, and I managed that, and I was Alex's manager for 8 years. So we had a good run.
Yeah. Very cool. I do remember when I was in the class. Alex did a few classes at A9, and I was fortunate to go to those. And I remember as he was going over the algorithms, I realized these do all lead to sort, don't they? I just thought, well, he must have just picked some algorithms he thought were useful. And they are useful, but they also are all the building blocks.
Yes, and if you go back, originally there were actually more algorithms, and some of them are finally coming back in. Things like IOTA came in relatively recently. But when Alex kind of put this together, and Alex and Bjarne had worked together at Bell Labs, and that's where the connection came in to get this into the C++ standard, is Bjarne thought it was too much to kind of drop on the committee, the whole body of work that Alex has created. And so there was this whole, this editing process of going through and trying to prune things down to the essentials. And, Alex will say, Bjarne was like, we got to remove that function. He's like, you can't remove that function because then nothing else works, right? You can only remove the leaf nodes. You can't remove the trunks of the tree, right? So yeah.
I remember, when I read about rotate, it took me forever to understand what it was trying to say. And then when I finally figured it out, it's like, there's an algorithm for that? And then I realized, no, this is actually a building block that you're going to use a lot.
Yeah. A lot of people don't realize that. I'm surprised you even brought up rotated, but a lot of people don't realize that.
Wasn't supposed to, was I?
No, you weren't. But, rotate and many of the other algorithms in there are very useful building blocks, right, to build up other algorithms. And rotate in particular, from kind of a CS theory standpoint, is particularly interesting because there's very different algorithms for if you have random access data or just bidirectional access or forward access. And there's a strong relationship between rotate and the minimum number of cycles and moves and greatest common measure, right? So there's an amazing amount of depth in what appears to be this relatively trivial algorithm.
Right. So tell us about your test results in the sense of these people who have, what is the average candidate who does this binary search?
Right. So the average candidate, I would say the average candidate does reasonably well. They usually turn in something that solves the problem. The problem's supposed to be, do this binary search in log n time. So, and make an argument as to why you believe it's to be log n time. They're usually not quite optimal. Frequently, they kind of blow it in their description. Badly, people have a hard time writing and explaining their code. There's very few candidates. If you've kind of made it that far, right, we've already interviewed you and talked to you, and so there's very few candidates who get to that level who fail out on first pass, even if the code contains a bug. Mm-hmm. Right. If we come in and a common mistake is people will do a binary search until they find an equal element, and then they'll turn into a linear search. And so we'll usually give people a round of feedback, right? We'll point out what the issue is. Mm-hmm. And surprisingly, that can be very telling, right? If people respond and they're like, oh, geez, that's kind of embarrassing. I see what you're saying. Or ask questions, I don't see what you're saying. Tell me more, help me out here. and dive in and try to address the problem, then that's great. Then frequently that turns into a job offer. The worst thing that you can do is argue. We've had people come in and go, yes, this deteriorates into a linear search, but if you have, random data, then on average that, right, and we're like, we didn't tell you the data was random, right, maybe it's all zeros, and right, so you'll occasionally get people who just don't respond well to criticism. And so part of the test is trying to see how do people respond to criticism, and how do they adapt. And even if their answer is correct, how do they respond if you say, well, yes, that's correct, but it's inefficient here, can you do better? Mm-hmm. Right? And some people get very indignant about that, so surprisingly. So that's kind of how it rolls together. Now, I will say we've had some spectacularly bad answers to this. I think the all-time worst, hopefully whoever it was doesn't see this, but this was many years ago, so I'm sure they've had a wonderful career since then.
But not at Adobe.
Not at Adobe, yeah. Maybe at Adobe, just not on the Photoshop team.
Oh, I see.
So we got the answer to this for binary search, and it was about 30 pages. Okay, and the code contained a whole test harness, and it was that the problem is stated as binary search for an int. And they said, well, they generalized that to binary search for any type that it inherited from searchable base class.
Okay.
Okay.
I didn't know that int inherited from searchable base class.
That's kind of a problem there, isn't it? So not really generalizing it. So they had like all this test case, and then this whole big harness to drive it, and then the algorithm for binary search, just not including all of the base classes and derived classes and stuff, was still about 1.5 pages of code, and spectacularly wrong from an algorithmic basis. And then the whole description was talking about, what a wonderful piece of work this was, because it was all object-oriented and followed all the best practices, and didn't once mention the algorithm in the write-up. So that was like, yeah, thank you for your time, right? Well, just set this one aside.
I'm kind of surprised you even read. I mean, someone hands you a 30-page. You kind of have to know going in that that's not really viable. Yeah,
going in, that's not really viable. At that point, it's kind of morbid curiosity.
We may have a show title.
Yeah.
I do really appreciate this. I had a project when I was working on the Microsoft, the Mac version of Outlook. Mm-hmm. And one of the things that we wanted to give was a feature where Outlook, the product, has access to the global address list, which is, for a given company, it's the list of all of their employees and vendors and everything. Everything they know about, it's in Outlook. And so it's an online system, but if you're traveling, you want to be able to make a snapshot of that. And so the feature we had was that we were going to download the global address list, parse it so that you could, mm-hmm. And because there was a lot of Windows expertise in the file format and all that stuff, we outsourced it to another company. And I talked to them a lot. I said, you should use the STL algorithm for the binary search. No, we don't like STL. Well, okay, just has to work. That's fine. And they brought it in. I had this little GUI had already set up over the API that we had determined. And the idea was, I was going to hit a character, and it should, if I hit a J, it should take you to the first name that starts with a J, right? Yeah. And I hit a character, and it practically froze. What? So I looked through the code to see, what's our problem here, and sure enough, they used a perfect binary search to find the first J, and then started going this way, one item at a time. And I, of course, tested it with Microsoft's GAL, and that's a pretty big, list.
Yeah.
So linear search back to the first J was pretty.
Yeah, there's only 26 letters in the alphabet, and there's a lot more names of people at Microsoft.
That's right. That's right. So
Yeah.
if I had input a complete name, it probably would have worked pretty well.
Yeah.
But it's supposed to be alive. You can do one character at a time as you type in. It's supposed to update.
Sure.
And it didn't.
It didn't go well.
Didn't go well. Didn't
Yeah.
go well.
Yeah. Even the kind of over-object-orientizing something, if that's can be a word I'll coin here. Before Adobe, I worked at Apple. Was there for about 5 years, and one of the things I worked on at Apple was the transition from 68K Max to PowerPC Max, and so we were doing the design for how we would do the emulator in something called mixed mode that let the emulated 68K environment and the native PowerPC environment kind of interoperate seamlessly.
So if you had some older code with some
newer code.
they could call into each other.
And since the old 68K machine, kind of everything was running in supervisory mode, this basically meant that you had to handle that you had to support 68K interrupts executing at PowerPC interrupt time, right? So it's a non-trivial kind of piece of work that we were putting together here. And of course, initially, it's like we don't have actual hardware, so we're writing the architecture and running the architecture, but it's really just doing mixed mode 68K to 68K or power to power on a machine to kind of vet the different pieces until kind of everything came together. And as we got hardware from the hardware group, we're trying to boot the operating system, right? Sections of the operating system are written as 68K, and so we're trying to walk this machine up, which means our debugging tool is a logic analyzer, right? So we're tracing code with a logic analyzer, and it's painful, and we want a debugger. And Apple's got a whole tools group, and they said, yes, we are working on the debugger, and this is dragging on, and we're like, we need a debugger, right? This is really, really hard. And we go in, and we like everything was very secretive at the time and compartmentalized, much as it is now these days at Apple. And we go in, and finally it's like get the executives to agree that we need to go in and see what this team is doing. And we go in, and they're like, oh, well, we have this wonderful source level object-oriented debugger that is beautiful, right? They have a class in there that's topcode, okay, and it's multi-windows and doesn't even there's no stub to support remote debugging or anything. And they're like, yeah, you're going to just run this and you'll be able to debug great. And we're like, we're trying to boot. Right. Right. If we could run your debugger, we'd be done. We'd be shipped. So we ended up grabbing the sources for MaxBug, which Max and MaxBug has nothing to do with Macintosh. It was a tool written by Motorola for low-level 68K debugging. So we ended up grabbing the sources for MaxBug and bringing MaxBug up inside of the emulator and adding hooks into that so that we could support PowerPC debugging and get this device going. But yes, that was just the taking an architecture way beyond what the actual needs are to a point where it won't work.
Mm-hmm. So I want to go back to something you said earlier. It doesn't surprise me at all, knowing Alex, that he was excited about being an engineer. Mm-hmm. What does surprise me is that when you showed him this massive object-oriented code base, that got him excited. I didn't think Alex was a big fan of object-oriented programming.
Yeah, so I wasn't showing Alex Photoshop. So at this point, I was working in Adobe's research group.
Oh, I see.
I reported to Martin Newell. If you ever see a SIGGRAPH paper and there's a teapot in there, that's Martin's teapot. So I'm reporting into Martin Newell. I'm looking in a research group, and I was working on something I've talked about them in the past, and they're very tied into relationships. A piece of work that I still kind of work on in my idle time, something called property models. Mm-hmm. And these are multi-directional data flow constraint systems. And so I was working on that, and there's actually a fair amount of kind of algorithmic interesting things in there, and things that you can prove, and the interesting thing was Alex found it very interesting, but then of course after we hired him, he told me I was completely wrong, which he was right actually. So working with them kind of
Was a bit of a challenge.
Was a bit of a challenge and shored up the theory, and for a while there, trying to talk about property models with Alex, as I would walk into his office and I would say, okay, so I'm working on this piece, let me explain it to you. Statement number 1, statement number 2, he'd be like, stop right there, you're wrong. And I'm like, no, this has to, statement 2 has to follow from statement 1. He's like, no, that's a contradiction. He'd write on his board and be like, there you go, contradiction, QED, wrong. I'm like, well, what's the right answer? He's like, I don't know, it's your problem. Right. I just know that this is wrong, so go back. And like one of the highlights of my career is actually walking through one of the algorithms with Alex and getting to the end and having him go, yeah, I think that's right. So that was different, and I think it's interesting. A lot of people don't respond well to people who are like, you're wrong, get out of my office. Right. Come back when you're right. Yeah. Why wouldn't they? They don't come back. I always say, like, try to work with people who are smarter than you are, right? And try to figure out how to engage them. And if they're dismissive of you, go do your homework, but be persistent, right? And don't feel like you can't come back and engage them. I think a lot of people are like, oh, that guy just shot down my work, I'm never talking to him again. And that's a lost opportunity, right? It's like in science, right? If you do an experiment and you get a negative result, that's a huge learning opportunity, right? Why is this wrong, right? And I think, I've known a lot of people over the years, not just with Alex, but working with other very smart people who won't engage them after a first interaction or a first couple of interactions, and miss out on a huge learning opportunity.
So how did Photoshop's code base evolve with you working on it, thinking in terms of the STL and thinking in terms of value semantics instead of object-oriented? Is it still...
It's still... it's at this point almost a 30-year-old application, right? And there are still files in there that start with a capital U. The reason for the capital U is because they were Object Pascal units ported to C++. The application was originally written in a framework called MacApp, which was at the time it was written in MacApp.
Spent many years with MacApp.
Yeah, many years with MacApp. So it was an object-oriented Object Pascal framework. And at one point, kind of Apple dropped support for MacApp, and then later picked it back up. It had this sorted history, but at the point where they initially dropped it, Photoshop forked, did their own port to C++, their own port to PowerPC, and it bears little resemblance to what you would consider MacApp anymore. But it's still, many aspects are kind of largely, still object-oriented under the hood, right? It's an awful lot of code to kind of clean up and clean out. But what we have is a team that's not fearful of kind of moving in new directions. And I think part of the power of generic programming is that generic programming is not just an or, it can be an and, right? One reason why I say, like, every object-oriented framework that I've ever seen is wrong is because if it was correct, then I could use all of them together, right? And that's rarely the case, right? It's like, oh, are you using framework A or framework B? I'm like, why can't the answer be I'm using both? And the answer with generic programming is you can use both, and you don't have to clean out decades worth of code to use both. In the last couple of years, the team has grown just a tremendous amount as we're trying to make this transition from it just being a desktop product to this ecosystem, something that's, you know, all your documents on all your devices all the time. And so we've been bringing new people in, and so that's presenting a challenge, right? You have to both bring new people in, and they have some level of skill set, and you're trying to raise them here, but you're also trying to teach them about, we know that is an absolutely horrible thing, but you know, it's still so well entrenched, and if you squint at it sideways, it can be a beautiful piece of work. Right. It's correct. It's not how we would work it today. It's very efficient. It's heavily tuned. Right. I was kind of surprised, you know, working on Photoshop for the iPad when we first brought up the prototype, and the prototype was really the entire core of Photoshop, and we could open up, you know, a gigabyte image in 40 megs of RAM without breaking a sweat. You know, and even people on the team and you know, in management, we're like, that's amazing, 40 megabytes. And we're like, why the heck is it 40 megabytes, right? We used to open documents this big on little 68K Macintoshes with, you know, 1/3 this memory, or just a small fraction of it, right? So that architecture is still in place, and some of it has been updated and modernized, and some of it hasn't. But they play well together. Like we just lit up in the shipping product a rewrite of the whole composite engine. If you think of Photoshop, you know, it supports layers, and all of those layers have to be composited, and you have, you know, layers and layer effects and all of these things going together. So it's a fairly complex compositing graph. And that was written as this big thing called U-merge. It was this big, nasty, macro-filled loop that nobody understood. That was horrible. And the team went through. I've given talks on data structures, and there's an Adobe forest. It actually got a mention in this talk, a data structure for representing hierarchies. And now the graph is actually written as a forest. And rewriting it let us light it up. So now it's GPU enabled, where it used to be CPU enabled. And now we can actually see the dependencies, and so now we have a GPU enabled core going all the way up through the stack, but that's still sitting on top of a virtual memory system to manage all of the tiles of your image. That's still written in the Mac app style. Right. So it's an and proposition. Right. The two pieces get to come together.
I can only imagine, what kind of scale you were working at, and the legacy issue.
Yeah, the legacy issue is bad. The scale is not as big as you would imagine. You would think a product that does almost $2 billion a year would have this massive team, but the team has been stable for many years at about 20 people. We've kind of more than doubled that in the last couple of years, as we've more than doubled the scope of the problem that we're trying to tackle. But yeah, I mean, it's been a relatively small team. A lot of the team has been there for a long time, right? So Sita, everybody just refers to him as Sita. I'm not going to attempt to pronounce his last name. Sita predated me on the team, and he's bounced on and off the team a couple of times. And for me, it's like I worked on the team like more than 25 years ago for a few years, and then I left and I did a whole bunch of stuff, and then kind of recently came back. And so I figure, eventually I'll go back to Apple and make my career a palindrome. But yeah, there's folks like Russell Williams, who you probably know. And it's amazing. You can like sit down with this team, and it's like, how many people have been here more than 20 years, and like half the hands go up. Right. So these guys really, really know the code base, and they really know what they're doing. Right. And they're very good. I've worked with a number of teams in my career, and I've been fortunate enough to work with some amazing people. and this team, even with, as if that were a bad thing, but we've brought in a bunch of people, and it's really some amazing talent. I think the Photoshop team is still a first class, world class team in what they do.
And no suggestions that we go back in and rewrite it all?
I don't think, even like taking it to mobile, there were people who were saying, in fact, when we kind of pitched this product, as far as it started with Sita and myself and somebody named Michael Kaplan, who did the initial proof of concept and launched this project. And when we kind of decided to pitch it, we didn't realize that there was already another team at Adobe that was attempting a bottom-up rewrite and rethink of what Photoshop was. And we kind of demonstrated that there's a huge amount of life in this code base. And so in some sense we won, and we ended up consuming that team. And that's been a huge boon, because they were doing a lot of GPU work, and it's actually that team that's lit up our composition engine to now be all GPU accelerated. So that was a wonderful thing. I still think that a company should always be trying to disrupt themselves. Right? If you were building Photoshop today from the ground up, you would make a different set of decisions about what you wanted out of the product, and that would lead to a different architecture and a different set of features and a different set of trade-offs, and a different product ultimately. And so I'm very pleased that we won, that we were successful in launching ours. I'm very disappointed, actually, that the result of that was killing another team that maybe could have been disruptive. Right. Trying to be disruptive of Photoshop is an incredibly daunting task, and so odds are that they would fail, but we would learn in the failure even if they did. And I think it's worth the investment for a company the size of Adobe to always be kind of paying for that. And I don't think as a company we do enough of that. We kind of, and I somewhat get it, having managed. It's like you only have so much budget and so much, and you're like, clearly this is where the money's going to be. Let's put our emphasis here. But you kind of always have to have that little side bet going on. And sometimes those side bets pay off. Right.
Well, it's possible that as a product it might fail, but might be a huge feature or a huge enhancement to Photoshop when they've got something.
Yeah. Early on in Photoshop, I had worked on Photoshop 3, and there was an effort to build something that was going to be Photoshop 4. And Thomas Knoll, who the original author of Photoshop,
a restart that would be 4.
No, not a restart. It was a build on, but it was a very significant architectural change. Very, it was at the time there were these competitors that were things like Live Picture, where it was more parametric editing and less kind of burning in the pixels, and so it was kind of a branch going more in that direction. Very forward-looking, but that meant it was going to be a long effort. And we acquired Aldus at the time, and so there was going to be a shortfall in revenue at a particular point in time. The only product that we had in the portfolio that could make up that shortfall would be to turn a release of Photoshop within the time frame. So myself and Mark Hamburg got pulled off of the Photoshop 4 effort to do what was going to be a Photoshop 3.5. And just the two of us, we were told, you guys go build a Photoshop 3.5 and don't disrupt the rest of this team. This has to stay on track. And towards the end, it wasn't completed with just the two of us. We sucked in other resources, but that happened when we went and gave a demo of where we were at about halfway through this process. And the product marketer was like, "This isn't 3.5. Like we're going to sell this as 4.0. This is huge." But the result of that is we had forked going back to 3 because what the effort in 4 at the point that we branched off was not stable enough to be a fork point. So we went back to 3 and forked from there, and we became mainline, right? So we became Photoshop 4. What was going to become Photoshop 4 got canceled, and a bunch of the tech ended up getting rolled into Photoshop 5. So even though it ultimately turned into a failed effort, and quote, we won.
Right.
I never viewed it as a competition. There was a huge amount of technology that rolled into the product, and if you kind of look at Photoshop at that time, it's like 4 was this huge release, and then we followed up relatively quickly with 5, with all of these, amazing features, right? And it was this huge bend in the curve for the product. So ultimately it worked out. But yeah, sometimes, at that point we were the side bet, right? Right, and it worked out.
With a happy ending like that, we are out of time.
Okay.
So we need to wind up and ask you to join us in wishing everybody safe coding.
Hey, safe coding, everyone.
Safe coding.